Today I'm going to discuss about depth of field and depth of focus definitely. And in this topic, we will try to cover a few more things, which is very basis for the depth of field, which is the concept of blur circle, and the concept of blur circle directly correlate with the pinhole and how pinhole functions. And concept of blur circle definitely again come when we going to talk about aberrations and all these things. So concept of blur circle and concept of depth of field and depth of focus and how it relates to the uh, pinhole aperture or pupil size and all these things, and its same principle applies in relatively in case of camera pictures and all these things. So let's go deeper to the depth of field. So this is the simple concept of depth of field. The range in a space over which object can be resolved is depth of field. Okay, but we do not use accommodation for resolution of the object. So it must be in a space where, if this is I, in an object space, obviously in an object space, not in an image space. Image space is there. So if it is in image space, it will be depth of focus, it will not be depth of field. So depth of field is in object space, which is in our reality, in outside of the eye. If that depth in the focus zone in image space, not in object space, then in image space it is called depth of focus. So sometimes focus, depth of focus and depth of field, sometimes people get confused with what is depth of field and what is depth of focus. Depth of field is in object space, depth of focus is in image space. It is in retina. So depth of field is, so let's take it in this example. Let me clear it up. So in this picture, let's consider we are focusing here. Okay, in this picture we are focusing here, but if we move object from here to up to here and from here to up to here, in this all this area we can see this object clear without use of accommodation. And in this zone we can see things clearly when we focus here and we change the position of the object. Still without help of accommodation we can see clearly, and that zone, that depth is known as depth of field. Basically that zone is known as depth of field, and we have to discuss how that depth of field zone increases or decreases. What are the main things, that main factors that are important when depth of field shrinkens or depth of field lengthen. What are that factors? That is very important point to understand. So the main point we have to understand is blur circle. What do we mean by blur circle? What is blur circle? Let's take example of this picture. Y, this blur circle is so small, and take example of X. This, in this blur circle is larger, and Z blur circle is also larger. Z is a case of hyperopia, X is a case of myopia, and Y is a case of emmetropia. An object conjugate with the retina is defined as a focus on the retina, isn't it? As I have previously told you, that when light comes from infinity, and if it is focuses on the retina, the infinity is conjugate with retina. So in this case we can say retina is a far point or infinity is a far point. If object is a point, then image is a point. Definitely, if object is a point, image is a point. So in this case, in case of emmetropic, if object is a case, image is a case. But in case if there is no emmetropia, if object is point, then image is not point but forms a blur circle, which is not exactly point. Point image is not going to be a point object, not going to be in point image. Point object going to be in blur circle. And at the same time for hyperopia it's same thing. Point object becomes blur circle at retina. So if image is focused anterior or posterior to the retina, it produces blur circle. So see, What pinhole does is to reduce the size of blur circle, isn't it? Pinhole reduces the size of blur circle. So that's why it creates what? Resolution. Visual acuity improves. That's why it creates resolution, because as blur circle reduces to smallest possible, then visual acuity resolution increases. That's the principle of pinhole, isn't it? So in case, so see, in this case, if the amount of the less defocused, if is small blur circle, more defocus is large blur circle. So the size of blur circle depend upon what? Amount of defocus. Means if the defocus is small, in this case, see, it is very nearby retina, so amount of defocus is less. That's why blur circle is small. It's very far from the retina focus point, and here it form larger blur circle. And size of the pupil, smaller the pupil, blocks the periphery rays and is smaller blur circle, isn't it? In this case, see, there is no uh, is larger pupil, so larger retinal blur circle. Is smaller pupil, is smaller retinal blur circle. Actually, putting the pinhole is also doing the same as this, if it is pinhole or if it is smaller pupil size. In both the case, refractive error is same. Can you notice that from the retina, the distance is both the case is same. But besides of retina, if there is a small pupil which act as a pinhole, then circle blood circle amount reduces. So doing whatever, if the amount, if the amount of blood circle, actually size of the blood circle reduces, it creates what? Larger depth of focus. But it's not about the circle, it's not about, actually it's not about the uh, blood circle, it's about size of the pupil. It's depend on size of the pupil. If size of the pupil, so let me tell you in this way. The size of the pupil is always inversely proportional to depth of focus or depth of field, because no matter what, depth of focus is conjugate to depth of field. It doesn't matter what you are telling. Depth of focus means in the retina, depth of fields mean in the field objective space, but both are same thing. Even dioptrically same thing, both are conjugate thing. But you must understand, the size of the pupil is inversely proportional to the depth of field. If size of the pupil is greater, depth of focus and depth of field decreases. If size of the pupil increases, sorry, decreases, is small, then depth of field or depth of focus increases. It's reverse. So in case of pinhole, as I have already told you, so B is out of focus, A is in focus. With pinhole, the size, can you compare this size of from out of focus, just putting pinhole, size of blur circle reduces, so that resolution increases. So it's a basic principle of pinhole. Sometimes some people, I have heard many people that telling pin what is the principle of pinhole, and they explain Styles Crawford effect and all these things. That's absolutely rubbish. Just you have to understand, principle of pinhole is to reduce the blur circle, so that increases the resolution. So depth of focus, see, I have told you this. This is depth of focus, which happen in the retina. This is depth of field, which happen in the objective space, and it is in image space. Both are same thing, but remember this, both are same in dioptrically, not in linearly. Linearly both are different groups, but dioptrically they are similar thing. Dioptrically they are same, they are just in conjugate point. So you must understand what do you mean by depth of field, and what it is in the objective space, it is in the image space. Okay, see, here we are focusing, and the range is this, isn't it? Range is this, the total range focusing at the 3 diopter, and range is 2.5 diopter and 3.5 diopter. What do you mean by that? one diopter is the range, and at the distance is 11.43 centimeter. Here you can see the distance is similar or not. Not at all similar. Distance is 0.37 centimeter in depth of focus, but I have already told you these are similar things. Dioptrically they are equal, they are conjugate point, one in objective space, one in image space, but not linearly. I told you 11.43 is not equals to 0.37 centimeter, which linearly not equal, but dioptrically yes, it's equal. So you can see this calculation in geometrical optics book too, and how it happens, and it's explained so beautifully. So you can pause this video and see how it's going to play. So depth of field, at, at any one moment eye is focused at only in one distance. With the depth of field, the object other than focus could not be resolved. Depth of field causes the pinhole effect, isn't it? Depth of field causes by pinhole effect, that is mainly dependent on size of pupil. It is possible for object far away and near object can be resolved, but without accommodation. It's centrally important. So can you see this picture? In this picture, this zone is clear, and away from this one it's blurred, and towards this zone is also blurred. But in this picture, very long area is clear. So in this picture, depth of field is larger. In this picture, depth of field is smaller, isn't it? And again, I can tell you one thing. For this, I think pupil size is larger, because larger the pupil size is smaller the depth of field. It's inverse relation for this. So pupil size is smaller if it is camera, then for this smaller aperture is used for camera. For this, larger aperture is used for camera. I think you have seen a lot of pictures like this, isn't it? So finally, I have used a lot of things from this book, and please, you want to see the calculation, please go to this book, which is very good book for a start. This is absolutely great book, and all time favorite of mine, Professor Dr. Jose Similis, and this book is my favorite book. I hope you'll go through it and try to understand more about it, and it's very good to understand these things because it will come later on in IOL design and IOL calculations and all these things. So till then, bye.